Welcome to the R learning session. In this session, we'll be talking about the fifth homework assignment for the fifth module. In this homework assignment, there are around 13 questions, and we'll go through each of them in every session. Today, let's deal with the question number 1. This is what it says. A manufacturer receives a shipment of 100 parts from a vendor. The shipment will be unacceptable if more than 5 of the parts are defective. Manufacturer is going to randomly select parts from a shipment for inspection, and the shipment will be accepted if no defective parts are found in a sample. How large does K have to be to ensure that probability that the manufacturer accepts the unacceptable shipment is less than 0.1 or 10%? That is, if it's more than that, then the probability will increase, but we don't want probability to increase. We want probability to be stay less than 0.1 and make sure you can maximize the sample. How do you do that? We'll maximize the sample but minimize the up to the ceiling is going to be 10%, not more than that. How to do that? Well, think about it. For this, we have to use a distribution called hypergeometric distribution. This distribution says that if there is a sample or there is a population and there are a certain number of items you are interested in, and you take a sample from that, and when you take a sample and you receive a certain amount of the items from the interested items in the sample, and what we are doing is we are looking at probability of finding certain number of interested items when we take a sample from the population. This is what we are interested in, and PDF says that, let's say, what's the probability of finding a certain number of items you're interested in from the whole population. So let's get started. Now after that, can you tell me what's the first thing we need to do to get started? The first thing we need to do is to remove clean the memory. That is, we'll do this to clean the memory. And if you clean the memory, second thing what we do is we need to import the required library. There's MVT norm, which have all the good packages such as statistics, probabilities, etc. Let's run this also. And now let's set our working directory to module 5. This is one thing you can do straight away. Now once we do that, then next thing what we need to do is we need to define the certain parameters or attributes for hypergeometric distribution. There are different attributes. That is, what's the total number of defective parts we are interested in. That's the main thing. We are interested in 6 defective parts, probably finding 6 defective parts in the sample drawn. And we also know that the total defective part shipment is 6. We know that. And what we also know is that if there are 100 parts in shipment, so there must be a 94 good parts in a shipment. We also know that. And now this is a trial and error. For this one, we'll do 68. And then this is going to be our function for our process. And once we do it, let's run this. 0.91%. Now, if we increase by 1, let's see what we get. 1%, it's not less than 1%, 10%. So therefore, 68 is a maximum number of sample I can draw to avoid rejecting the shipment. So let me quickly summarize what we learned today. We learned about the equation about manufacturer wanting to avoid rejecting a shipment, and for that, the way is to get the to manipulate the number of samples it draws so that it can avoid rejecting a shipment. For this, we want to use a hypergeometric distribution, and in our case, when there are 6 defective parts and 100 samples, the maximum size you can draw was 68. So that's all for today. I'll see you next learning session. Thank you so much.